Untitled problem number 1, naming solids and their parts. Refer to the figure at the right. Describe the base, name the figure, and name line segment RL. So we're just considering the cone at the top, which we'll get to in just a minute. That's part of our answer, I believe. So first, describe the base. Well, there's one base in this figure. That base is a circle, which I could write the word circle here, or I could possibly underline it here. The figure is a cone. Notice it matches the definition of cone. It has a single base that is a circle, and it has a single vertex. And our final, we're asked to name line segment RL. Well, knowing that the base is a circle and that line segment RL seems to extend all the way across that circle and pass through its center, RL is called a diameter of the circle. So there we go. The only base, because there's only one, is a circle. The figure is a cone, and line segment RL is a diameter. Now a similar quick check problem. Refer to the figure at the right. So now we're not discussing the cone anymore. Name the figure. Line segment JK, and the points J and K. And there's a good chance you want to refer to your notes to answer these questions. Example problem 2, recognizing solids. Set design. A stage crew for the school play constructed the ramp shown. Name the 3 solids used to construct the ramp. This is a neat problem. Section A. Well, section A appears to be a triangular prism. Notice our 2 bases are triangles, so it is a triangular prism. Section B. Well, I didn't know whether section B should be called a rectangular prism or a square prism. And potentially, if our bases were squares, we could call it a square prism, and that'd be a more specific way to describe the rectangular prism. But looking at the dimensions shown, I see that section B has a base that will be 7 feet by 4 feet, and that makes it a rectangular prism. Section C, well, section C is interesting. What we need to consider for section C is that its bases, well, one of its bases is facing us, and the other base is really facing away from us. But they're both parallel bases, and they're congruent. So we just need to count the number of sides and determine what is the name of the polygon representing the bases of section C. Well, there are 1, 2, 3, 4, 5 sides, so it's a pentagon, thus making section C a pentagonal prism. And a quick check problem. Name 2 solids that can be used to make up section C. So imagine section C being cut into 2 pieces, creating 2 different solids. Name them. Example problem 3 involves identifying skew line segments. So first we really need a definition of skew line segments. Skew line segments are neither parallel nor are they intersecting. And that may seem like an interesting concept. Consider this figure. Here we have 3 line segments. 2 red that look to be parallel, and those 2 red ones are not intersecting. And then a blue one, which we can call a transversal, that looks as though it is intersecting both of those red lines. Now we're used to seeing figures like this in 2-dimensional space. So those 3 line segments are all sitting on a flat surface or are all in the same plane. And so they are intersecting. But what we need to imagine in order to understand skew line segments is having line segments that are in different planes. So what if we imagine just one of those red line segments and we imagine 3-dimensional space? So rather than thinking of this as being a flat surface, think of that red line segment as, well, as like a log lying on the ground in 3-dimensional space. And now imagine the blue line segment as, well, as maybe being like a tree standing upright, but notice the base of the tree is not in line with the log lying on the ground. These 2 line segments, they're not parallel, but they also never intersect. That's possible because they're in different planes. Now, if the two line segments were in the same plane, they would either have to be parallel or they would have to intersect in at least one point. Since they're in different planes, they're skew line segments. So back to our example problem. Number 3, we're asked to name a pair of skew line segments and a pair of parallel line segments in the figure at the right. So to imagine a couple of skew line segments. Well, how about line segment EB and I have a lot to choose from here. EB and line segment CD is a good one I notice. Notice EB and CD are not intersecting, and yet they're also not parallel. Those two lie in different planes, therefore they're skew line segments. Having chosen EB, notice I could also have chosen, well, I could not choose AB because those line segments, EB and AB, share a common point B. EB and BC share a common point, or would intersect. EB and FG, those would work. So lots of choices. We're also asked to name a pair of skew line segments and a pair of parallel line segments. Parallel line segments. Well, I see some. So parallel line segments can always be thought of as being in the same plane and never intersecting. So I'm noticing BC and FG look to be parallel line segments. And your quick check problem is open-ended. Name a pair of intersecting line segments in the figure above. Are they skew line segments? And check your understanding problems from this section.